Hi, welcome to another episode of We Talk Science. I'm here today at the Westerdijk Institute with Professor Pedro Crous, who is the director at this institute in Utrecht in the Netherlands. Dr. Pedro Crous, thank you so much for your time today. Could you introduce yourself to us, please?
Sure, Sheba. I'm Pedro Crous. I've been in the Netherlands now, I think, for 18 years. I originally come from South Africa, where I was head of Department of Plant Pathology at University of Stellenbosch. My speciality is fungal biodiversity, and that is why I was hired as director in 2002 to head up this institute. The Westerdijk Institute is the world's largest living fungal collection, and I'll tell you a bit more about that as we go along. But it's a truly amazing place to work because every fungus you can possibly think of, we more or less have in the collection.
What is the importance of having a collection like this? How would this collection be important for mankind, let's say, now and in the future?
This collection is hugely important. Firstly, it's important because it's a living collection. I can go back to our oldest fungal strains that Johanna Westerdijk collected from the late 1800s, and they're still alive, and they still produce the same metabolites they did because of the way we preserve them. We also do research in how best to preserve these fungi so that they stay metabolically active. And our research is basically focused on three themes: agriculture, health, and industry. And these three areas actively use the collection. We send out about 6,000 strains per year to different companies and institutes and individuals and universities who use these strains in their collection. And this is something that only increases, it will never decrease. And per year, we get about 3,000 new deposits, so it keeps on growing. I said we're the largest collection. I think we've got about 100,000 in the public domain, in the public collection. But we estimate that there are millions of species of fungi. Nobody knows how many. So we continually collect. They're everywhere. Most people think of fungi as a little mushroom that the gnome sits on. That's fine, that is also a fungus. But we specifically focus on the microfungi. And these are the fungi you don't see with the naked eye. And they are everywhere, in the air, on surfaces, in plants, endophytes, you don't see them, in the soil, in water, everywhere. And that's why it's so exciting.
So tell me, why are fungi so important? What is the fundamental thing that gets you, for example, excited about fungi? You mentioned the medical, the industrial applications. Can you tell me a little bit more about that? Why are fungi so important to us, and why should we care?
Well, fungi have a positive and a negative side. So most people only know the negative side. So fungi cause spoilage and rot. So at home, you will have an issue in your bathroom probably with fungus growing on the walls if you don't open the window enough when you shower. If you go into your kitchen and you look at the vegetables lying there, they're starting to rot because nobody ate the apples or nobody did something about the pawpaw or whatever. And in your fridge, you'll have similar problems. So fungi are the natural decayers of the world. If it weren't for fungi, we would be up to our ears in dung. They break everything down and put it back into the soil where it feeds the new generation of trees and flowers. So that's what fungi do. But fungi also have a positive side. You cannot have an organ transplant. You cannot have a hip replacement or something if it weren't for the beneficial effects of fungi. They produce metabolites that get built into medicines that we need. They are absolutely essential. We'll have no bread. Bread won't rise. We'll have no wine. Can you imagine that? No beer either. So a really amazing blue cheese, fungi. When you have a problem to fungi is, for instance, anti-dandruff in the morning when you shower. That's also fungal negative side again. Athlete's foot, when you're traveling on the plane for days to some weird hotel in Asia. So that's also fungus. So it's positive and negative. And in the Institute, for many years, we generated lots of our income from the negative aspects. People phone us and say there's a problem in their homes, or a factory arrives with green cheeses or a weird yogurt or who knows what, and we solve the problem. But now, in the last few years, we have also focused strongly on the beneficial sides of fungi. And that's why the collection is so important, because these different fungi produce different metabolites that are very, very useful. So we've got a group that focus on enzymes that use the fungi and see which enzymes they produce that make a certain industrial process more efficient and would save a lot of money, better and more greener for the environment, biofuels, etc., name it. And we've also got another new group in the Institute that focus on novel metabolites, looking for new antibiotics, for instance, looking for metabolites that stimulate plants to grow better in drier environments. All these things are possible having the fungal collection that we can now actively harvest and screen for these applied applications.
Could you give me one example of the most famous discovery of a metabolite that was produced by a fungus, for example, and how are we actually harnessing that for in today's world?
Well, I think probably the one that everybody knows the best is penicillin. During the Second World War, it saved thousands of lives, produced by Penicillium rubrum, and cyclosporin from Tolypocladum inflatum, a fungus that allows organ transplant, and the statins now from Aspergillus for cholesterol. The list goes on and on. There are many, many medicines that you take and you don't realize that the ingredient comes from a fungus. And there are many more, many more. So this is, I think, our challenge for the future, to improve quality of life. But this is but part of it. The other aspect is to preserve what we have. And that's also where I think our Citizen Science Project comes in.
Okay. Tell us more about the Citizen Science Project, please.
Well, the Citizen Science Project is quite interesting, and it started with, it's a spin-off, shall I say, from a project we have with the Gates Foundation in Ethiopia. So in Ethiopia, they've got big problems with a parasitic weed called striga that parasitizes sorghum. And sorghum is a staple food. And with this parasitic weed, then they have nothing to eat. So it's a massive problem. And the Gates Foundation actively invest in these food crops, trying to help these people with cheap biological remedies to address this problem. So we were looking at soil, and specifically at the fungal genus Fusarium, finding species that would target striga and thus enable sorghum to grow and be harvested. And when I saw the incredible diversity of microbes in soil, I thought this would be an excellent target for something like a Citizen Science Project. And then we came upon the idea to launch this project, world famous, A Fungus with Your Name. That's what it's called in English. It sounds better in Dutch. And Wereldfaam, 'n skimmel met jou naam. So we thought that children could, in the Netherlands, collect soil in their gardens, and then we isolate all the fungi. And if there were new fungi in the soil of the gardens that the children send here, we would name it after the kids or their families or their schools. And we didn't know what to expect, because the Netherlands has been studied quite intensively, specifically for soil fungi. We had old Walter Gums here in the Institute who worked on it for many years. And we started this, Walter said to me, "You're not going to find much, you know." So I thought, But we were amazed. We were blown away. There were so many new species in Dutch soils that we thought this is just too much. So we've named probably more than 100 already, and there are more to come. And it appears to be a treasure trove for novel fungal biodiversity. And now we are at the point where we're going to launch a new citizen science project this year with schools again in the Netherlands, but also in foreign countries. And we're working specifically towards the International Mycological Congress in Amsterdam in 2022. And there we want to have children of the world on the stage with their new fungi. But we're going to take it further. In this new project, we're not only going to describe the fungi and leave it at that. JGI, the Joint Genome Institute in Walnut Creek in California, have indicated that they are prepared to do the genomes of all the new species. Okay. Jerome Kohlmeier upstairs, a new group leader, said that he will do the HPLC profiles looking for novel secondary metabolites. Our question being, and using the genome data, is there a chance that there's a new antibiotic in someone's soil? Who knows? Or some new medicine or something, some new metabolite with an amazing application. So that will be the new focus of the new Citizen Science Project. And in 2022 in Amsterdam, these children from around the world will be there receiving their certificates with their new fungi. And hopefully we will at that stage also know what these fungi do and how they can be applied to benefit the quality of your life.
That is absolutely amazing. So at what stage is the second part of the project right now?
We are just launching the second part of the project. We are presently setting up the website so that children will be able to log on and see their GPS location, whatever country, and track what has been isolated from my soil. The plan is that we start isolating in September. This will be with stagiaires. We will probably use students, master students or so from the universities to help with the DNA isolation, to send this to the US. We will need other students to help with the metabolites, for screening for the novel metabolites. So it's a lot of work, but I think incredibly exciting.
And incredibly important, actually, as well.
Well, yes. The thing is, you know, we need to preserve biodiversity on our planet. It is of utmost importance with global change, warming, and loss in biodiversity. It's just startling. When I started at this institute, mornings I used to cycle here. There were all kinds of bunnies hopping around on the fields. Beautiful. It's all gone. It's now been built up. There are new buildings, new institutes. That biodiversity is lost. And people refer to biodiversity and link to it because they can see it. Our component they can't see. But when that plant is gone, the hundreds of species that were living inside the plant, on the roots, on the leaves, in the stems that you couldn't see, endophytes, they're gone too, because their host is gone. So everything is linked. And when you lose one species, there's a domino effect. And at the end of the chain, you lose all these important fungi that could produce the metabolites we need that could cure cancer or AIDS or something important. Who knows? So we desperately need to make people aware of the holistic sense of biodiversity. Even our component, which is the microfungi, that's invisible to the naked eye.
So I have a question for you. Why do you think that the assumption that all of the biodiversity within the Netherlands had already been characterized, that was, we basically started off with that assumption that you wouldn't find anything, terribly new, and now you're saying that actually that is not true, that we found hundreds of new species now. Why do you think that is?
Simple. The first DNA sequence of a fungus landed in GenBank in 1991. This work was done in 1980, before molecular techniques. Now with molecular techniques, we can accurately track and find species that weren't possible before. And some of them are extremely slow growing. We've got better techniques. We can separate them. We can get them in pure culture. Probably it wasn't that easy in years ago, you know. So we're better at locating them, growing them, tracking them, finding them, using them. So that's why we are seeing now many more than previously.
Okay, I understand that. Okay. According to you, what is the single biggest challenge when it comes to how fungi can grow and contribute to humankind? What is the biggest? I guess what I'm trying to ask is, how do you see it growing, and what would be your end game for this project and for your for the Biodiversity Center?
Well, the Biodiversity Center is here to stay. It's the home of the microbes of the world. This is where people place them, and we make them freely available to humanity for researchers globally. We've got one of the largest databases in the world with up to, 3,000 users per day, unique ones that just log on and download data. So we make the fungi available and the metadata, and in years to come, now already they have DNA barcodes, but in years to come they'll also have genomes. So it just keeps on growing, and all these data are interconnected and are used by researchers more intensively so now to find answers to their specific questions. It may not be a fungal question, but it could be a related question where the fungal component is very important. So the Institute has a crucial role internationally because it's one of the few in the world that do this kind of thing. Obviously, our challenge is always to fund it, to fund these kind of initiatives like citizen science. We have no funding for that. We do it out of our own budget because we think it's so crucially important. You only need to see the joy in the face of one of these kids to realize that this is good and this needs to be done. So we are making people aware of the beauty of biology on this planet, and I think that is a good investment for the future.
Thank you. So the Institute actually changed its name recently to the Westerdijk Institute. Could you tell us more about why that happened and who Johanna Westerdijk actually is?
Oh boy. When the Institute was established in 1904, the first director was a young girl, aged 22, called Johanna Westerdijk. And she needed a job, they needed a director, the two ends met, and that was a marriage made in heaven, and she did that for, I think, 53 years. Unbelievable, for 53 years. So there were terrible hard times during the First World War, during the Second World War. At that stage, these fungi were kept on tubes, and agar tubes need to be replaced every 6 months. And the food for the fungus, the common medium, was potato dextrose agar. In those days, there was no food during the war. They had to take their own food, the potatoes they wanted to eat, to make medium to save the collection. So it was a terrible time. And there are many books written about this. Also the discovery of penicillin, the Germans who wanted the collection to get the penicillium collection. I won't go into that. But Johanna did a stellar job. She was also a strong supporter of women's rights. She trained 56 PhDs, half of them were women. Her family tree, her academic family tree, is global. I think the biggest node is now in Africa, where many of her students are, and their students, so they are propagating even stronger than in Europe. So it's an amazing success story. And in 2017, it was 100 years ago that she became the first female professor in the Netherlands on exactly the same date and the same time. that she became professor, we changed the name of the institute from the Centraal Bureau vir Skimmelkultures to the Johanna Westerdijk or the Westerdijk Fungal Biodiversity Institute. And 2017 was also named the Westerdijk Year. There were many activities, many symposia. We also got a new research wing on the institute focused on these aspects that we've been discussing: industrial mycology, application, relevance. And so it was a very exciting time for us.
That sounds absolutely wonderful. And now the Institute also publishes some publications as well. You have books and you have periodicals that you are publishing. Could you tell us a little bit about that?
The Institute has 2 book series. The biodiversity series, which is normal books on specific topics, and I've got many of them. And then we also have the lab manual series, which is a series of books linked to courses that we teach in medical mycology, in industrial mycology, and in general biodiversity. And a week or 2 ago, we've just published a new version of our lab manual on biodiversity. And as you can see, beautiful life cycles of fungi, and in the end, a lot of practical examples for coursework. So these manuals are being bought by people who need to run classes internationally to teach students about fungi. And then we also have 3 journals. Our flagship journal is very heavy, Studies in Mycology, which we publish in collaboration with Elsevier. And then we also have Personia, which we do with the Naturalis, Natural History Museum in Leiden. And the third one is Fungal Systematics and Evolution, a new journal. And they're all 3 open access, and they've got slightly different focus areas. And we really have great fun doing these journals. You may ask, why do we need our own journals? The problem is that some of our papers are so massive, no normal journal would consider them. And that's why these journals were initiated long ago. And it enables us to publish big revisions of major important genera of fungi, and to beautifully illustrate them regardless of the number of pages involved. So we show these fungi in all their glory and natural beauty, and we don't care if a paper is 100 pages or 400. If it's a good paper, we publish it, and that's why we do it in our own journals.
One last question for you.
Mm-hmm.
If you were faced with a person who was at the brink of their lives of figuring out what to study, how would you convince this young person to study fungi?
Oh, that's a very exciting question. I think there's so many aspects of fungi that this person could go into. And I just touched on a few. I didn't even get into genomics and bioinformatics, the data side of fungi. Very exciting. But there's so many amazing discoveries to be made. I think we've had like 5 fungal Nobel laureates already in the past, and I'm sure there'll be many more to come. The big discoveries on this planet will be made at the microbe level with fungi. They have the potential to change our quality of life. What better challenge? Why work at the McDonald's if you can do this?
Thank you very much for your time, sir. I really appreciate it, and I think that our audience has learned something very, very new about fungi today. So thank you very much.
Thank you for the interview. I loved it. Thank you.